Right, I'm just mounting a junction block on the wall now. This is where basically the two load cells come in. So we've got the two cables coming up. I'm trying to keep these cables away from any other electrics because they are susceptible to a bit of interference. So this box here will basically take the two inputs from the load cells and combine them into a one output for the amplifier, which will then go to the computer. The idea of that is basically the software that I'm using only accepts a single load cell input, as most dynos these days have just your one break on them, but this one's obviously got two. So the idea of this box is to combine the two resistive load cells into one output. You'll notice there is also trim pots on the. It's actually a 4 input one, but obviously I'll only be using the 2. That will then keep all that enclosed in there with the lid on the top. Just sort of sits on the top there. It's got a nice rubber seal in it to keep the elements out, and they're all sort of proper glands. So that will sit there, and then the output will then go up into the main sort of electrical box, where the amplifier and then the software interface in-out box will be. Right, so I'm working on some wiring this evening. As you know, I've got the two load cells mounted in the frames. Got a speed sensor here ready to mount up. Sensor I'm probably going to mount it somewhere on the edge here, and then put the magnet in the side of the in the roller. Although it might be better to try and mount it in the shaft actually, just so the centrifugal forces are kind of lower. Obviously when it's in there compared to when it's out there, it's spinning kind of a smaller distance. So I've ran all the cables up through. I've kept the load cell cables isolated because they're very, very low resistance signals and very susceptible to interference. So they come up through, and I've just wired that into the summer box. So you've got two inputs with the two trim pots, which will need adjusting at a later point. And then it's outputting up to the main box up the top here, into the load amp. So that amplifies it to a 0 to 5 volt signal, takes its power from a 12 volt power supply on the left here. That also feeds the Dyno interface, USB interface. They recommend using a battery to reduce interference to start with, and then go over to a 12 volt supply, but I'm just going to try it as it is. If we get any problems, I'll put it onto a battery just to make sure that's not the problem. All of the main sort of connections are now on that terminal strip, just so it's easier to work out what's going on. The old 12 volt supply is still running the solenoids for the air brake and the load and unload valves. I'll just keep it separate to try and keep interference to a minimal. All the load cell cables are in different conduits than the signal, the data ones. So I've kind of made it so these are all the auxiliary inputs here. So we'll be able to input sort of like boost gauges and AFR, EGT, or anything really, anything that outputs either resistance or 0 to 5 or 0 to 15 volt. We can kind of input into the computer and log that alongside the power graph. There's also some outputs on the Dyno box on the left here. I'm hoping to use one. One's really meant for the air brakes, but I don't think I'm actually going to use that, just because I don't have a problem with using the mechanical button, and there's a lot of times when we want to just reverse over the pit to use the pit for non-dyno things, where we just want to quickly lock the brake, turning the computer on and stuff every time we want to do that. But there is also another output that I intend on connecting up to some potentiometers and a relay to run the cooling fan, the extractor fan, just so that every time the rollers stop, the extractor sort of goes down to 20 Hz just to keep the noise down, and then as it detects roller RPM, to bring the extractor back up again. The actual Dyno box, I haven't mentioned it before, the Dyno package is the actual Dyno software and hardware package that we're going to be using. It comes from Australia, a really helpful guy called Darren, ironically. I spoke to him about it and we kind of got the kit together. Really, really cost effective compared to most other professional solutions. So that's what we're going to be using, their hardware interface and also the software on the computer, which I haven't mounted yet. So we'll see how that goes once we're up and running. So I've just got some more wiring to tidy up, and then we're going to start putting some load on the cells to see if we get any voltage out the amplifier. Right, as you can see, I've got the computer down here now, so I've just turned it on to make sure everything's working. That's sort of the front interface to the Dyno 3 software. I got sort of the logging graph and some gauges at the bottom. I'll show this in a bit more detail in another video, but the computer's running. Just mounted it on the wall there above the control cabinet. Yeah, power from there. Obviously the interface is all plumbed in. just fired up the water pump because I have to make sure I've got no leaks after reconnecting all of the water lines. I've also now mounted the speed sensor on the front roller. So you've got the sensor, I've made a little angle bracket there. So that sensor screwed in there, and there's a small magnet bolt screwed in the side of the shaft there. I've tried to keep that in as close as possible to the centre of the shaft, just to kind of reduce the centrifugal forces on it. Right, you're probably wondering what we're doing up here. So I've got the dyno connected up now, and we're getting readings from the amplifier into the computer. So we need to calibrate basically now, so that the computer knows what voltage sort of means what weight, or what tension, however you want to look at it. So obviously we can get our 0 voltage just by leaving everything rest. That's your 0 voltage, we can calibrate that no problem at all. So now we need to put a known weight on to see the output from the load cell amp, and then tell the software what weight that that voltage means. So being the farmers we are, we have a nice collection of John Deere weights lying around, some spare ones here. So John Deere claim it's 50 kilo. It says 50 kilo on the side. I don't know how accurate that is. So what we're going to do is we're going to drop it in the sheep scales here to weigh it. These are really accurate, so we will know now, well, if they're accurate, and if they're not, what weight it actually is. And then we can make a frame to hold this above the load cell to calibrate. So if Chris sticks it in here, we're zeroed out here in a minute, so we'll just see what these actually weigh. Like I said, they're labelled as 50 kilo, and they are actually 50 kilo. Okay, so they are exactly 50 kilo, that's good. Right, so now that we know what that is, we can go down and somehow mount it. Right, what you can see here is the homemade calibration bar that I've just made. So the top there is for hanging the weight on, just a nut to tighten up again so it can't fall off. I'd cut a couple angles into it, and then you'll see it just basically slots on to the end of the torque arm. So you drop it into position, that slides on there like that, and then you put the bolt straight through the holding hole, and obviously the nut on the back, and then that basically sits like so, and then that allows me to hang the weight. Right, so I've just finished calibrating the second side, so you can see I've got the arm mounted on the torque arm with the tractor weight hanging off it. So you can see I've got that hanging directly above the load cell. I've now calibrated and trimmed the second input so that they both output exactly the same with 50 kilograms on them, and I've just made a note of the readings on the computer. So I'm now going to input that data into a linear input, because these load cells are linear, so as long as you've got 2 points, that'll give you a fairly good reading. So I'm going to get that input now, and we'll get a car on here and see what happens.